Sequences and series. So, again, arithmetic means that we're constantly adding the same value. So it's increasing by 2, increasing by 2, increasing by 2, or decreasing by 5, subtract 5, over and over again.
What does that say?
When you are doing that, we want to maybe find partial sums again. Again, there are problems out there, real life problems that we can come up with, and I'll show you some in a minute, where you might want to sum up the first however many terms of a sequence. So if you would like to find what we call a partial sum, partial because the sequence goes on to infinity. So there are infinitely many terms in this sequence. So this is always considered a partial sum because there's no way we can ever reach the end. So partial sums, again, are when I give you a starting point and a stopping point and I ask you to add the things in between. So I will always give you the starting and stopping point. There are two different formulas out there that work for partial sums of arithmetic sequences. So these are specific for arithmetic sequences. You can use this formula or you can use this formula, it doesn't matter. Sometimes, depending on what you're given in the problem, it helps you make the decision of what formula to use. So if you come across a problem and you're given n, a sub 1, and a sub n, well, I'm going to use the first one because everything's there to plug in, right? If I'm given something with a constant difference and the n value, then maybe I'm using this one. So it just kind of depends on what I'm given as to which one I use. There's no wrong answer because they're both going to give you the right answer if you do the math correctly. There's no wrong answer, but like I said, sometimes one is a little bit easier to use than the other time-wise and plugging stuff in. All right, so let's look at some examples. The first example, do you see how I've drawn arrows and separated it? The first example I'm going to do both ways. So I'm going to show you with both formulas so you feel comfortable that you could use either. Here is our sequence. What do we always assume about this one? What's my assumption? It's A1. We always assume it starts with term 1. So unless I tell you, hey, it starts with term 7, always assume that it starts with term 1. That's a fine assumption to make. We want to add up or sum up the first 40 terms. So we want to sum term 1 through term 40. I'm going to start with this one and try this one first. So S sub n equals. First of all, what's my n value that I'm adding up to? 40. So I'm going to replace my n with a 40 because we know what that is. So then I go here, that's the same thing, so that's another 40, that's how many terms I'm adding together. Do I know a sub 1? What is it? 3. Do I know a sub n, which in this case is a sub 40? No, so I need to find that, and then I'm going to divide by 2. So let's find a sub 40 really quick. So let's start here and think about this sequence. So I'm going to start with a sub 1 is 3, a sub 2 is 10. What did I jump up by? 7. Okay, so think about your formula from yesterday. A sub n equals a sub 1 plus the constant difference times n minus 1. What did we just say the constant difference was for this problem? Plus 7. Positive 7. And what term number did I want to find? 40. So I'm going to plug in 40, and I'm going to plug in 7. So I'm going to calculate that 40th term and figure out what its value is. So I get 3 plus 7 times 39, which gives me 276. So that goes here. Now do I have, everything I need? I have all the things I need. So I'm going to go ahead and type it in. I've got 3 plus 276. I'm going to divide it by 2. I'm going to multiply it by 40. 5,580. Yeah? So that would be my answer. Let's look at it the other way with the other formula. So we're going to do S sub 40. So again, we're plugging in 40 for n equals, what's my n value? I just said it, 40. So 40 divided by 2. There's my bracket. I have a 2. The 2 is just part of the equation. Times a sub 1. What was my a sub 1? 3. Plus n minus 1. What was my n? 40 minus 1 times the constant difference. What did we decide that was? It was a positive 7. And again, usually I put mine out front because, I don't know, I just like it better out front than out back. So go ahead and plug that into your calculator. You're going to get the exact same answer. Plug it in so you trust me. You are going to get the exact same answer though. So do you see how you can use either equation? And maybe even the second one was almost a little bit easier and faster. So again, you can choose either one. And you might want to choose based on the problem and based on what you're given. And then make your decision from there. Did we try it? We got the same number when we plugged in? Okay, make sure you use enough parentheses and you're typing it in correctly as well. That's obviously important. All right, example number 2. We are given a sub 1, we are given the constant difference, and we are given n. So which of those formulas might be a little bit better than the other?
Second one.
Yeah, the second one because I have all the things. All right, so n over 2. So I want to go up to 10. So 10 over 2. Bracket. 2 times a sub 1. What's a sub 1? 55. Plus n minus 1. What was my n again? 10. So 10 minus 1 is 9. I'm just going to do that math. Times the constant difference. What's my constant difference? They told me. 12. Okay, so plug that into your calculator. Again, being careful of parentheses and division and making sure we're doing all the right things in that aspect. Yeah?
You give these formulas on the test?
I don't remember what I have for this test. I'm going to have to look. I want to say yes. I think part of the reason why I give them is because when you think about the formulas themselves, they're also similar. And I think that's what bothers me the most is that you could easily interchange one for the other. I don't remember though, so I'll have to look. It's either that or I give you a note card. So it's a yes, it's just which way. Okay, what'd we get? What'd we get? Somebody had to plug it in. 1,000 what? 1,090. Perfect. Okay, now we come down to our notation down here. We've got our sigma friend. And so we're going to do the same thing. We're going to use the same formula. And again, you can use either. We'll see which one we like best. But we've got to like thread this stuff out of that sigma notation. So first of all, it's asking me to start at term 1. Could I find term 1 really easily if I wanted to? Let's find it. A sub 1. What is a sub 1 if I plug in my 1? 7. Right? 2 times 1 is 2, plus 5 is 7. Can I find my a sub n? N is 15. Can I find my a sub n pretty easily? Yeah, let's find that. So I think I'm headed toward the first formula, the one on the left. A sub n would be the same as a sub 15, right? If I plug in 15, what do I get for the value of that term? 35. So again, I think I'm going to use my first formula. That one looks better to me than the other. So I've got n, so n is 15, times a1 plus a2. What was my a1? Plus my a2, 35, all over 2. So again, make sure you type it into your calculator correctly. So basically what we did is we found the first and 15th terms, if you want to fill in the blanks. And truly, overall, we are finding S sub 15, the partial sum of the first 15 terms. Okay, plug it in, make sure you're using your calculator correctly and putting parentheses in all the right spots. Look up here when you're done and make sure your answer is a match to my answer. And then when you're ready, you can turn the page. We're going to do 3 more examples. They're all just a little bit different, but not much. And I don't think any of them are like going to be super tricky. They are, one of them is an application, but it's not like we're going back into the airplane with the wind and the 60 degrees north of south or north of east. We're not doing all that. All right, flip to the next page. So 3 more examples and we're out for today. Pretty quick notes compared to what we've had in the past. All right, here is our equation. Or not our equation, but here is our sequence, and they're already showing me the values summed together. Okay, so you can think of a comma being between each of these, and that's the sequence, and then they're already showing me the start of the summation. They want me to sum up to the first 18 terms. So the first thing I want to do for this one, what's going to work best, is to find the common difference, or the constant difference. And then I'm going to want to find the nth term, which is basically the equation for what's going on. And then I'm going to plug it into one of those formulas that we had a minute ago to solve it out. So what is the constant difference? How would I navigate from 13 to 2, from 2 to negative 9? Negative 11. All right, a sub 1 is what? Making our assumptions. 13. It's always going to be the first thing. And in this situation, our n that we're going to go up to is going to be 18. So if I wrote my original equation, a sub n equals a sub 1 minus 11 times n minus 1. That would be my general equation that would give me these values in my sequence. So this is what I have here. Step 3, now that I've kind of summarized all this information, now I want to go to S sub 18. Which formula do we want to use? The one on the left or the right? I think the right, because I think we have all those things we'd have to actually plug in for 18 to find a sub 18. So I'm going to go with the one on the left. But again, if you want to be a rebel today, you use the one on the right and you see that you get the same answer. Here we go. N divided by 2. So if I'm going to 18, n divided by 2 is 9. The 2 is part of the equation, times a sub 1 plus n minus 1. What's n minus 1 in this case? 17 times the constant difference, which is negative 11. So again, kind of simplify as much as you can with each step. Get your final answer. Tell me what you get. Yeah. Did we get negative 1,449?
Yeah.
Perfect. Okay, that would be my final answer for that one. And again, if you use the other formula, you should get the same thing. Okay, last problem. There are 2 parts, though. Remember, I kind of warned you about this when we talked about it yesterday, how they like to do like ideas of like Wharton Center or theaters and thinking about the seats, because there's fewer seats in the first row and then more in the next and more in the next. Okay, we have 15 seats in the first row. We have 2 additional seats in each subsequent row. How many seats are in the 20th row? All right, here we go. We want to find a sub 20. I'm going back to our equation from yesterday. What's a sub 1 for this problem? 15. Plus, what's the constant difference? 2 times n minus 1. What's my n? 20. 20 minus 1 is 19. So the first thing it wants me to find is just how many seats are in row 20. I'm not summing anything right now, so make sure you read every question. They're all just a little bit different what they're asking you for. So how many seats are in row 20? 53. I have 53 seats in row 20. The next part says, what is the total in the first 20 rows? Is that one a summation? Yes. Which formula do you want to use? The one on the left or the one on the right? I would go one on the left because do we have everything? Yeah. So S sub 20 equals, we want the first 20 terms, it's N, in parentheses, we have a fraction over 2, and we're going to take our A sub 1, what was our A sub 1 again? 15, and add it to our A sub N, which was 53. So add those up, divide by 2, multiply by 20. I usually do it in just 3 little steps when I calculate it. What do we get? 680. Agreed. So that's the number of seats in those first 20 rows total. Okay, that's all your homework is going to be tonight. Tomorrow is kind of a stop day for a second. Not because we've done anything that I would consider like earth-shatteringly hard, but because we've done a lot of little things. So tomorrow's kind of a stop day, and we are going to get a review worksheet tomorrow. And then we will pick up again with 12-3. Again, we don't have a quiz over this chapter because it just doesn't really lend itself to that with the amount of information. But we are going to take a test, and it will be next week on Wednesday. So we are headed very much in that direction.